You are required to find the area of the blue triangle from two unequal squares. Label G, C, B, H, D, F, and O. Also, angle labeled G, C, D equals 45 degrees and label angle alpha, beta, and theta. Use Pythagoras theorem. The square of C, D equals the product of 2 and 36, so that, by solving for the square root of the equation, C, D equals the product of 6 and the square root of 2. Substitute values and we have that line labeled D, O equals the product of 4 and the square root of 2. Let us find length of the line G, O from triangle GOC. Use cosine rule. The square of G, O equals to the product 2 and the square root of 5, which is equals to x. Thus, line labeled D, O equals to the product of 4 and square root of 2. Let line G, O equals to x, line D, O equals to y, and Z be the opposite side of angle theta and the diagonal length of the red square BU. Hence, square U equals to the product of 2 and the square of x. Solving for U equals to the product of 2 and the square root of 10. From triangle DGO. Using cosine rule and substitute values obtained, we can find the value of cosine beta. Cross-multiply and simplify, we have that cosine beta equals to 1 divided by the square root of 5. Thus, cosine alpha equals to cosine 90 degrees minus beta, which equals sine beta. We use trigonometric identity to resolve it. By trigonometric identity, we solve for sine beta, substitute values and simplify. We have that sine beta equals to the product of 2 and the square root of 5, which let us find the length Z. From triangle with angle alpha using cosine rule. We have equation in Z. Recall that square x equals to 20 and cosine alpha equals the 2 divided by the square root of 5. Substituting values in the equation Z. We have that the square of Z equals to the positive difference between 56 and 48, which is equals to 8. This is written as the product of 4 and 2. Find the square root of the equation and we have that Z equals to the product of 2 and the square root of 2. We solve for angle theta from the blue triangle using cosine rule. From the equation in square Z. Substitute values and make cosine theta the subject of the formula. We have that cosine theta equals to 2 divided by 5 after simplification. By trigonometric identity, we solve for sine theta and substituting value for cosine theta, and we have that sine theta equals the square root of 1 minus the square of 2 divided by the square root of 5, which is equals to 1 divided by the square root of 5 after simplification. Therefore, the required area of the blue triangle A equals to the product of u, y, and sine theta all divided by 2. Substituting values obtained into the area equation and simplify, the result equals to 8 square units.